Almost there! This is level 20, and as far as I know, this is going to be the last one, your last step toward becoming a sophisticated, distinguished 8th grade level equation solver. So you're almost there, almost congratulations. Last thing I want to teach you is how to recognize how many solutions an equation will have. So, you know the drill at this point. Make this the title on the next free page in your math notebook, then close it, think, all that good stuff. All right, so yesterday we looked, or yesterday, whenever you did the last one, might have been yesterday, might have been just a minute ago, we looked at equations that have no solutions or infinitely many solutions instead of just having one. For the first 18 levels, there was always one solution, x equaled a certain thing. And then yesterday we ran into things like this, where when you started solving this, you might get 15x minus 27 or plus negative 27 equals 15x plus 1, and then you might start to solve this, and you might get something weird like this, and say, well, that is not possible, which means solving this is also not possible. There's no solution. There isn't a single possible value of x you could find that would make this true. We also had ones where the opposite of that was true, where no matter what you did, the equation was true. So this one, if I start to solve, combine some like terms, I would get 6x over here and 4. Do some distributive property over here, I would get 6x and 4. And now this one's going to be true no matter what. They match on both sides. Anything I put in for x is going to make this true. If I keep simplifying it, maybe I take 6x away from both sides. I get 4 equals 4. Well, that's always true. The last one, we got something that can't be true. This is true no matter what. Or if instead of dealing with the x's, I dealt with the 4's, I might take 4 away from both sides. Both those cancel, and I get 6x equals 6x. Of course that's true. That's true no matter what. If I wanted to go ahead and divide, all I find out is x equals x. No matter what I do, I end up with something always true, and that means everything's a solution. So that's where we were yesterday. Today I want to teach you how to tell which of those is going to happen without necessarily solving it all the way. I want you to be able to look at an equation and recognize how many solutions it'll have quickly, even if you don't solve it. So my goal is to help you decide, if you see one, will it have no solutions, 1, or unlimited? So let's look at 3. So I want to give you some shortcuts kind of here, and I'll explain them on this I do, but I want these to be eventually a shortcut to where you might at least be able to answer this question for an equation fairly quickly. Even if you don't solve it all the way out for this one, you may be able to say, oh, but I know it's going to just have 1, and it won't be this, and it won't be this. So here we go. So here's what you'll look for. You'll notice we only started this business of different numbers of solutions when there was variables on both sides of the equation. There's variables here, and there's variables here. So in the first 2 levels of that, we always still had one solution, but some weird things happened yesterday, and here's what you look for. If I started to solve this one, just looking at my variables first, I'd end up with negative 6x on this side, and I already have negative 6x on this side. If you have the same number of variables on both sides, the exact same amount, I have negative 6 of them, that's your clue that you're either going to have no solution or infinitely many solutions. Don't know which yet, but I'll tell you that's the clue to look for. Like if I go back to the connect, you'll notice I ended up with the same amount of x on both sides in both of these. That's how you can tell. So this one, after a teeny bit of work, I can tell they're both going to have that. Okay. This next one, teeny bit of work, if I start my distributive property on this side, I'm going to have negative 4x on that side. And when you combine some like terms over here, you'll have 6x over there. Those don't match. That's definitely going to be your one solution equation. If those don't match, you'll just start to do some work like normal and you'll find the solution. You know, I would probably like add 4x to both sides. And then there's no more x's over here, and there's 10 x's over here, and there's some number over here. And it's just going to unfold like you're used to. So when those don't match, that's a typical one solution equation. I could work this all out. I'm not going to bother, but I could. So let's look at this one last. A little work here. I'm going to have 3x on this side, just looking at my variables right now. And when I combine like terms, I'm also going to have 3x on this side. Boom, that's my clue that I'm either going to have no solution or infinitely many. So if the variables match on both sides, the coefficients really are what match, not the variables. If your coefficients match, you're going to have one of the strange scenarios. So now, which one? And how do we tell that without going through all the work? So to tell that, we look at the constants. To tell if they're going to have one or the other, we look at these coefficients. To tell which one, we look at the constant. So if I continued this, my constant would be 15 on this side. And my constant is already 15 on this side. When those match 2, that's when you end up with infinitely many solutions. When everything matches, after a little work, it's not always apparent if it matches, that's when you have infinitely many solutions, because whatever I do, I'm going to get a match here, right? Like if I want to add 6x on both sides, those go away, and I get 15 equals 15. That's always true. Or if instead of dealing with the x's, I dealt with the 15s, I would get negative 6x equals negative 6x. That's always true. So that's why that shows you the infinitely many ones. When both the coefficients and the constants match, that's when you get that. No solution is when your coefficients match, same number of x's, but the other part doesn't. The constant won't match. So if I continued this one, I'd have a constant of negative 3 here, and I have a constant of negative 10 here. Coefficients match, constants don't. Because, not that you'd have to do this, but now if I started to solve it, I would add 3x to both sides. And that's where I'd get an impossible thing. I'd get negative 3 equals 10. So when that matches, but those don't, that's when you get none. So that's your trick to do this quickly. Notice I didn't ask you to solve either one. I just asked you to recognize how many. That's very distinguished, to look at an equation and be like, oh, I can tell it's going to be this, this, or this. Let's do an example together. If you'll pause right now, write these 3 down, and we'll take a few notes to help you recognize which is which. Okay. So let's write down our conditions first at the bottom here. So let's start with infinitely many solutions. You're going to get infinitely many solutions when the coefficients match on both sides. And the constants match on both sides. Both. That's when you get the infinitely many solutions, when everything matches. You're going to get no solutions when the coefficients match on both sides. But the constants don't. That's when you're going to get no solutions. Different numbers, different constants, but same amount of variables, same coefficients. You're going to get one solution when the coefficients don't match. And that's it. So we're not going to solve these. we're just going to find where they go kind of quickly. So here we go. So I like to start by looking at the coefficients, right? This one, if I separate my sides, this one's going to have 2x combined with negative 4x is negative 2x on that side. And this one's going to have negative 2x on that side. So one of the two things here is going to be the case. It's either going to have none or it's going to have infinitely many. Let's look at the variables on the next one. The left side's going to have 6x. And then we have 7x minus x. That's also 6x on that side as well. So that's another one that looks to me like it's either going to have one solution. Either going to have no solution or infinitely many, because my coefficients match here and my coefficients match here. Okay. Last one, let me separate. I will have 6x on this side. And combine like terms, only 3x on that side. Coefficients don't match. I can already tell you where that goes. If the coefficients don't match, you're off on one solution. You don't even need to look at the constants. It doesn't matter. So that one you would solve any other old way, and you would be able to figure out x equals whatever it is. So let's go back now to these other two where the coefficients do match and decide which one's which. So now we've got to look at the constants. The difference here is in no solutions, the constants don't match. Infinitely many they do. So this one here, my constant, I'd have 3 combined with 5. My constant would be 8. Here I would have negative 2 times 4. My constant would be negative 8. They don't match. Negative 8 and 8 aren't the same thing. So unless I have made some kind of mistake here, I don't think I have. Those do not match, even though they look similar. You've got to be real careful with your signs. 3 and 5 is positive 8. Negative 2 times 4 is negative 8. So that's going to be a no solution. Because after I deal with the two x's, I would end up with something like 8 equals negative 8. And that's impossible. So if you even want to write that, the constants don't match. Okay. Doesn't look like they're going to on the other one either, so I probably intended for them to match on the one that we just did, but they don't. So, oh well. Negative 3 times 5 over here is going to be a constant of negative 15. And this one has a constant of 8. I bet you I meant for the last one to match. They don't. So here also, constants don't match. So we end up with another no solution. So I'm sure I wanted one where they both match, but it didn't. So over here, if these were both positive 8 or they were both negative 8, we would have an infinitely many solution example. Don't tell anybody, but I'm just going to leave it. We can have two no solution ones. That's not wrong. We just don't have one that fits there. But just to remind you how it would have worked, if I go back here, if they both do match, that's when you get infinitely many. So that's just a shortcut to do this quickly. Sometimes I'll just ask, and on your practice for this one, I'm just going to ask how many solutions does it have. You don't actually have to work it out and find what it is. Hope this made sense, y'all, and this is the last one. Congratulations. I hope the practice goes well, and I hope your distinguished level assessment goes well, and you are truly a distinguished algebra problem solver. Congrats, guys.